The intellectual movement known as the Cognitive Revolution represents a great conceptual transition which took place within psychology and philosophy between the mid to late 20th centuries. One of its major features was the failure and gradual retreat of behaviorism. From the beginning of the 20th century, this had been the predominant paradigm in psychology and to a lesser extent in philosophy of mind. I will argue that behaviorism was an extreme form of empiricism, influenced by the doctrine of logical positivism in the philosophy of science and fundamentalist reductionism in physics. Behaviorism radically rejected mental constructs because they cannot be anchored in observable and verifiable entities and processes. Behaviorism tried to eliminate all the mental states of which folk psychology is composed. Cognitivism reversed this position, accepting the reality and causal efficacy of inner mental states. Gardner and Lakoff and Johnson identified two distinct phases of the cognitive revolution. In this first section, I'll give a brief overview of the nature and themes of the two stages and provide more detail later. Phase one of the cognitive revolution coincided with and was very much influenced by the development of the digital computer. The independent reality of the mind came to be accepted by analogy with computer software. The mind was conceptualized as the brain's software. Consequently, this first phase conceived the mind very much in terms of syntax, algorithms, and mathematical relations, to the neglect of biology and neurophysiology. The second phase of the cognitive revolution reacted against this abstract mathematizing of the mind. Phase two turned instead to biological and neurophysiological approaches in search of explanations of mind and consciousness. Phase one of the cognitive revolution was specifically attacked by Umberto Maturana and Francisco Varela and several others. They characterized it as cognitivism, which incorporated representationalism and functionalism. There were two main thrusts in their critique of cognitivism. Firstly, that the mind is embodied, meaning that the mind should not be seen as an abstract entity separate from the body, but as inescapably part of the body and deeply influenced by its embodiment. And secondly, a strong anti-representational stance involving rejection of the traditional mind-world dichotomy and a deep skepticism regarding a pre-given world independent of organisms. As we shall see, Lakoff and Johnson then used the idea of the embodied mind to try to explain how thought and language are based on sensory motor metaphors. Alongside embodiment emerged the concept of embeddedness, i.e., the notion that all organisms, including human beings, are embedded in a particular environment, influencing it and being influenced by it. This is the concept of the echo niche, and it is through interactions with this and possibly a sequence of such niches that organisms, including the human species, evolved. In discussing the human brain, Morris Edelman stresses the importance of what he calls the critical triad, which always includes the body and the echo niche together with the brain as an indissoluble unity. Finally, another emerging area of research which has had a role in undermining cognitivism is computer brain simulation, which has come to be known as cognitivism. This uses analog computers, also known as parallel distributed processing, to create simulations of neuronal networks. In practice these days, such models are very commonly generated on digital computers. These models are much more similar to real neuronal activity than the simple logical gates of digital computers. They model real networks of units in which signals are free to follow many different parallel routes. In the routes which are most used, the signals become stronger and more powerful, very much in line with Hebb's ideas about reinforcement in the brain. While digital computers are rigidly programmed to follow rules, analog computers can learn. They use feedback to reinforce and weight the most effective signal pathways in their networks to physically incorporate their learning in the structure and functioning of their brains. This challenges cognitivism's digital view of brain functioning, i.e., that it consists entirely of symbols being manipulated by the rigid rules encoded in predetermined algorithms.